Dear audience and my dear honorable Mama Assalamu alaikum. This is Aminul Islam. Would like to welcome you all in this presentation. In this presentation, I would like to discuss about mm, field effect transistor, that means FET. This presentation presented to Raunuk Jahannam, lecturer, Kirin University of Bangladesh, presented by Aminul Islam ID 201001137. So here is my content. I actually discuss about the output characteristic curve of a different type of FET. And secondly, this is the mathematical term. It will see the later. Generally, there are two type of FET: junction field effect transistor and metal oxide semiconductor field effect transistor. That means JFET and MOSFET. JFET also two types: N-channel or P-channel, and MOSFET also two types: depletion mode and enhancement mode. And depletion mode also two types: N-channel and P-channel. Enhancement mode also two types: N-channel or P-channel. First of all, I would like to discuss about output characteristic curve of N-channel JFET. This is the N-channel JFET. The graph between drain to source voltage VDS and drain current ID. This is the three regions of the it is the ohmic region. This is the saturation region, and this is the breakdown region. It will be the pins of a region. What is the ohmic region? What is ohmic region? When VGS equal to 0, the deflection layer of the channel is very small and the JFET acts as a voltage controlled resistor. Active or saturation region. The JFET becomes a good conductor and the controlled by the gate voltage VGS, while the drain to source voltage VDS has little or no effective. This is the breakdown region. The voltage between the drain to source is high enough to the case and the JFET resistive channel to break down and pass uncontrolled maximum current. The graph we got from the graph the value of VGS, the source voltage VGS will become more and more negative. Then the value of drain current will reduce. Drain current will reduce. And at 1 voltage, this drain current will become 0. So this voltage VGS is known as the pinch of voltage. So you see the drain or the output characteristic of the JFET. And if you see the transfer characteristic, this is the transfer characteristic of N-channel JFET. This is we can see the P-channel JFET output characteristic of the P-channel JFET. The graph between drain to source voltage VDS and drain current ID, but here this voltage VDS drain to source voltage is negative and VGS gate to source voltage is positive. So as you can see, As we keep on increasing this voltage VGS, then the drain current ID will reduce, and at the pinch of voltage this drain ID will become 0. And whenever this VGS is negative, and it will so we are now I will discuss the output characteristic of type depletion type n channel MOSFET. Here we can see the n channel output characteristics of depletion type MOSFET. The graph between drain to source voltage VDS and drain current ID. We got from the graph, as the value of gate to source voltage VGS will become more and more negative, then the value of drain current will reduce. And at one voltage, this drain current will become 0. So this voltage VGS is known as the pinch of voltage. So if you can see the drain or the output characteristic of MOSFET, then it looks like quite similar to the N-channel JFET. But this MOSFET also works for the positive value of VGS. If you see the transfer characteristics, it this is the transfer characteristic of N-channel depletion type MOSFET. Now we can see the P-channel depletion type of MOSFET. The gap between drain to source voltage VDS and drain current ID. But here this voltage VDS, drain to source voltage, is negative and VGS gate to source voltage is positive. So as you can see, as we keep on increasing this voltage VGS, then the drain current ID will reduce, and at the pinch of voltage this drain current ID will become 0, and whenever this VGS is negative, then the value of drain current ID will be even higher than this IDSS. And similarly, if you see the transfer characteristics, then this is the transfer characteristics of P-channel depletion type MOSFET. Now we can see the output characteristic curve of enhancement N-channel enhancement type MOSFET. This graph between VDS and ID for the different value of VGS. So as you can see, as the value of VGS will increase, ID current will also increase, and this parabolic curve show the locus of the voltage VDS, where the drain current ID will get saturation. ID current will get saturated. So the transfer characteristics show the relationship between the input voltage VGS and output drain current. It is the transfer characteristic of N-channel enhancement MOSFET. This is the threshold volt. Now we can see the output characteristic of P-channel enhancement type MOSFET at this curve between VDS and ID. Now we can see this voltage VDS and the voltage VGS will be negative, and the drain current ID and the drain current ID will also follow from the source terminal towards the drain terminal. So as you can see, if from the graph, as VGS become more and more negative, then the drain current ID will increase, and whenever this value VGS of greater than VT, then the MOSFET will operate in the cutoff region, and similarly, if you see the transfer characteristics, then it will be mirror image of the N-channel MOSFET. This is a brief overview of the P-channel of MOSFET. Now I will discuss the mathematical term of depletion cap MOSFET. Here we can see the value of IDS is 10 milliampere and VGS of equal to -8 voltage. So we can find out it is N channel, is this N channel or P channel, and calculate ID at VGS negative 3 volt and calculate at VGS positive 3 volt. So as you can see, we know that this VGS of equal to negative volt, so it will be N channel MOSFET. For the VGS equal to 3 volt, then we will get the ID equal to, we know the ID equal to IPSS into 1 minus VGS by VGS of equal to whole square. So we have got the value of ID equal to 3.9 milliampere. And for the VGS equal to positive 3 volt, then we can find out the value of ID equal to 18.9 million. Thank you everyone. This is my project presentation. Thank you everyone. This is my presentation.